Welcome to Intermediate Algebra, Chapter 2, Section 2. We're going to talk about slope of a line and rate of change. Those two things are pretty much synonymous. The slope of a line can be calculated by finding the change in y values between 2 points and dividing by the change in x between those 2 points, very frequently referred to as rise over run. A line that's sloping up and to the right has a positive slope, down and to the left has a negative slope. If it's a horizontal line, it has a slope of 0, and a vertical line has an undefined slope. More specifically, in order to calculate the slope of a line, y2 minus y1 over x2 minus x1, where x1 and y1 are the coordinates of one point on your line, and x2, y2 are the coordinates of another point on your line. So in order to find the slope of the line that passes through these 2 points, one thing that I like to do to help keep myself organized is I'll often label these x1, y1, x2, y2, or you could just label this as point number 1 and point number 2, and then let's do some quick arithmetic. Our slope, represented by m, is equal to a fraction. y2 is 6 minus y1 is also 6 over x2, which is negative 3, minus x1, which is 4. That gives us 0 over negative 7, and 0 divided by anything other than 0 is equal to 0. So the slope of this line is 0, which means it is a horizontal line. And if you were to plot these 2 points, that would be very clear. Over 4 and up 6, to the left 3 and up 6. The fact that we had to go up 6 in order to arrive at both of those points definitely is going to make this a horizontal line. Parallel lines have the same slope. And if 2 lines are perpendicular, then they meet at a right angle, which you don't need to ever really work with, 90 degrees being a right angle, but just realize that perpendicular lines meet at a right angle, and their slopes are opposite reciprocals of each other. So let's suppose in number 2 that line 1 has a slope of negative 3/5, then any line that's parallel to it will also have slope negative 3/5. And if the line that you're working with has a slope of negative 7/2, then a perpendicular line to it is going to have a slope of positive, not negative, 2 over 7. So you take the slope, flip it, and change the sign. If the slope of our line had been 3, then the perpendicular line would have a slope of, think of the number 3 as 3 over 1. So we change the sign and we get negative, and then when you flip this fraction, you would get 1/3. So again, from a slope of 3 to a slope of negative 1/3. Those would be perpendicular lines because they have opposite reciprocal slopes. In this application problem, we have a vendor who has learned that by pricing hot dogs at $1.25, their sales will reach 123 hot dogs per day. Hot dog. Brutal. Raising the price to $1.75 is going to cause the sales to fall to 101 hot dogs. Well, at least they're slinging fewer hot dogs. I guess that's a good thing. So let's let y be the number of hot dogs that the vendor sells, and x be the number of dollars per hot dog, and we want to find the slope of this linear equation. So again, our y is going to represent number of hot dogs, and so x is going to represent price. We're seeing the graph over here on the right side. We want to find the slope. We'll call the slope m, and that is equal to Now remember, you've got the $1.25 is affiliated with the 123, and a price of $1.75 correlates to 101 hot dogs. So I'm going to take number of dogs as my y values. That goes in my numerator. So I'm going to do 123 minus 101. And then we have to make sure that because this was essentially y2, and this was y1, we need to make sure that the numbers that we put in our denominator appear in the same order. So that means that the $1.25 is x2, so we'll put the 1.25 here, minus excuse me, x1, which is $1.75, and from there it's an arithmetic problem. 123 minus 101 is 22, and 1.25 minus 1.75 is negative 0.5, which gives us a final slope of negative 44. Okay, negative 44. Let's put that into context. Remember that the numerator was representing number of dogs, and the denominator was measured in dollars. And so this 44 actually means number of dogs per $1. Interpret the slope in the context of the problem. I find that having units on there helps me make that interpretation. And what this slope tells me is that for every increase in price by $1, I'm going to have a decrease in number of dogs. Not just one hot dog decrease, but 44 hot dogs decrease. So interpreting the slope in the context of the problem and in sentence form, I would say that I would sell, or that the vendor would sell, 44 fewer hot dogs for every $1 increase in price. Raise the price, sell fewer hot dogs. Sounds reasonable. This linear equation models the number of hot dogs y sold per day when the price is X dollars. Find the number of hot dogs sold when the price is $1.50. You can see that just by labeling the equation with some units, it makes it easier for me to know where am I supposed to plug in this given value. So the $1.50 is definitely going in as an X value. Y, representing the number of hot dogs, is going to equal negative 44 times 1.50 plus 176. I can already tell I'm going to need a calculator because I'm going to have to do arithmetic. I don't like trusting my brain to doing arithmetic. However, this arithmetic I can do. This is going to be negative 66, and then I need to add 176. That's actually the same thing as 176 minus 66, and that arithmetic I can do in my head. That is 110. So by increasing the price of the hot dogs to a total of $1.50 per hot dog, the vendor is only going to sell 110 hot dogs. According to your model, how many hot dogs would the vendor sell if the price was $4 per hot dog? We know how to figure that out. We take the number 4 and we plug it in for X. Y equals negative 44 times $4 per hot dog plus 176 equals 44 times 4. How about 4 times 4 is 16, and 16 times 11 is 176, plus 176 equals 0. So if the hot dog vendor prices the dogs at $4 per hot dog, he or she isn't going to have a lot of heavy lifting to do because they're not going to sell any hot dogs. So this word problem is, you'll notice they use this word models right here. So this linear equation is considered a model. It's a mathematical representation of something that's happening in real life. And in your homework assignment, you're going to see some other word problems where you might have to actually create the model for yourself. Don't hesitate to draw some diagrams, write out some lists of ordered pairs in order to get a feel for whatever pattern it is that's developing. And sometimes I like to actually start out with y equals mx plus b, and then think about, what's my input value represent? What does the output value represent? Keep units in mind as you're working through a word problem. When your x value is 0, that's going to destroy this entire term. So when your x value is 0, sometimes that's considered as a starting point or an initial value. And that x value of 0, as we talked about in the previous section, can help you figure out your b value sometimes. If you know that your x value is 0 and you know what your y value is at the starting point, that's going to end up being your b value. So just keep moving the pieces around and trying to fill in the blanks, and I don't think that you're going to have a whole lot of trouble with this section. I hope that's helpful, and I look forward to seeing you in section 3. Thanks.